Professor Jones, I don't know if you can hear me, but through Zoom we can't hear you, or like if you're talking, we can't hear you through our end.
Can you hear me now?
Yeah, we can hear you.
Yeah.
I fucking turned, that says volume is at 0 up here. Yeah, I know we got an echo. It fucking says volume is 0. All right. All right. Can you hear me now?
Yeah.
Yeah.
Well, at least we don't have feedback. All right, there we go. All right, so we're looking at what's going on here. X is being assigned the value of 5. X pointer is being assigned the value of an address. This is called a pointer. We flag pointers with star. Picture, I don't know how else to describe it. I'll draw a picture of it shortly. I can turn down that volume here just so I can get this. But it's still anyways. Interesting. Okay. You can still hear me, right? Can you guys hear me?
Yeah, we can.
So we're just checking some C-outs. This one should be spitting 5 to the screen. Ampersand is the address of X. It should spit out where it is if it's hexadecimal. X pointer, delay of the sound is really weird. Why can't I? I have my audio. Oh wait, yeah, my audio is muted. I don't know why I'm hearing shit through my screen. Okay. It's definitely coming from this. So, it's fucking with me, Jesus. Okay. So it's going to spit out the address, and when you put the asterisk in front of it, it dereferences. Is this, did you guys find in there, or is this too awkward? Okay. This spits out what's contained there. So we should get a 5, yeah. Okay. I hope it's just that. Gonna happen. Let me should still be feeding it. We'll relaunch. Recording in progress. We're just gonna have to wing it. Alright, back to sharing screen. I had volume turned muted. I had volume level set to 0. I didn't actually fucking push mute. I don't know what the difference is. Going volume to 0 should have made it so this thing didn't produce any fucking sound. Right? Alright, so, here we go. Where are we? You guys can still hear me, right?
Yeah, we can.
Yes, there we go. Okay. Let's run it. Let's see what happens. So we got 5. We got our address as an hexadecimal. And XPTR was this third line. It's an address. Same address, because we know what it is. And the star dereferences it. We'll look at some of this other stuff later. Let's just finish looking at that section now and talk about it a little bit. Zoom into the way. There is another way to write that line. You can do int star xptr equals address x. And these 2 lines do the same thing. It fucking changed it. I put the asterisk over here. Those are identical. I think the second one's confusing as fuck because the asterisk in front is coming with the reference. So treating it as a pointer is confusing as hell. I don't recommend the second one. This is shitty. Looks like we so don't do that. I wanted to point it out. We can also do the same with array. Let's get nice and nice with it. So, it's a nice long name. She liked it. She uses it all the time. She works on Discord stuff. How long is this array? That's kind of long. Let's go with the string. Let's go with it. How long is that array? 5. Why? Oh, crap. It's right there. Don't forget that it's terminated by the so let's see what's going on here. We're making a pointer to the first value of A. We're going to see out A. We're going to see out. What's going on here? So we've got 1. Our first see out after we got this part right here, that is what we see right there. So we signed A on to the array A. It's 5 characters. And when we did the C out of A, this is the one. We do the C out, dereferencing starting at A1. It started with U instead of J. It started with array start at 0. There's your reminder. Indexing starts at 0. So that's in a reminder there. What happens when we see out the A pointer? We got that right. Line right here. See out A pointer gave us on again. Give us an address like seeing out the pointer up here gave us the address. X pointer here gave us the address of 5. Doing the C out of the pointer of the array gave us what was in. So that's interesting. Something to do with array components. And then what's going on with the fourth one? Passing it as an integer. And that's got to be the first one. Let me do this. So it spit out the address. And we cast it as an integer. Oh, shit. It's doing it in the product. And then what's going on with the 40? It should be giving us garbage because the array doesn't have 5 steps or 6 steps. The array only has 5. We counted it in 1. So what's going on here is going 6, 7, 58, 9. For some reason it's incrementing up. 0 to 7, or 0 to 6. So it's doing 7 steps, even though the array was 5 steps. So the thing is, when you start with A, it's pointing to the first element, the address of the first element. And then what it's doing is it's just adding to the next thing and looking at the address. So it doesn't matter if the array is still going on. So looking at the address and just doing what is it each time. And so that's what counts the array. And which is fine because we're looking at addresses. And it being only, it only being one thing is actually telling us that each character is just 1 byte. So we're taking that 1 byte from it. For things that are bigger, each step is different. Yeah. Can you hear me now?
Yeah, we can, but like there's like a lot of noise, like the hours, waves.
Testing. Yeah, I turned off the zoom on the thing. I wanted the zoom there because that way I can share the document camera pretty easy. When I need the document camera, we might just have to fucking deal with it for a few seconds, have the fucking noisy background, and then turn that thing back off. Okay. Where was I? All right, so I put the ampersand back here. Now let's see what we get. Fuck, still the same thing. Let's talk about it after lecture. Okay. So these are the same thing. This doesn't give us the address for everything in it. It just gives us the address. The first element. I'm going to uncomment that shit out. Comment this stuff again. That was the new addition. Let's take a look at pointers and pointer arithmetic. So this declares an array of 3 elements called B. Then we set up a B pointer. Sets up B pointer to point to B0. Okay. Maybe I'll do it after the code part show that way. So here, this should be showing us what? B pointer points to B. Well, let's take a look. Let's run. You know what? Let's do this. Let's bring that line back. So where are we? I'm going the wrong way. There you go. So B pointer is doing that. It's giving us the address of the first element. The asterisk. I need to do this. There we go. Now I can have them both up. So the asterisk is dereferencing the first element. And then this is called pointer arithmetic. We're adding 1 to B pointer. We're adding 1 to the address. What is that doing? And we're seeing, we're just doing a C out of it. It's showing us the next address spot. So when you do addition on pointers, it's just showing you the next address, not that it does not adding anything to the elements. You're not changing the elements, you're just changing where you're looking. The pointer is fuck, for anybody that's played World of Warcraft, it's like fucking Hunter's Mark. Effectively, it's pointing a target. There's a giant fucking blinking target pointing at that motherfucker. It's right there. If we add one after,
like this is still like just adding one to the address and then I'm saying be pointed with the asterisk and then plus
the pointer with the asterisk, then +1. Okay, let's try that. Like that? It does not like that. I was going on the way he said. Okay.
does that add to the
Wait. I'm gonna undo it because I just. Oh wait. Okay. Yeah. So what do you think's gonna happen?
I think it will like dereference it first and then whatever the value is there it will add one to.
Let's find out. Great thing about computer science. You can explore. Sure enough, 1 to 2. Did it change the value? Did it actually change the value of B, what was stored there? Or did it just add 1 to the value? So this added 1 to the first element of B. And printed that to screen. What is this bad boy going to do? Has it changed what's stored there? Let's check it out. Did we actually affect the value? No. So doesn't change the value in the array. Doesn't change the value in the array. So we just saw that. So that's handy to use. You'll actually end up using that quite a bit when you, because in this class, as we go delve deeper, pointers are the easiest way to move about what we're going to do. Going from when we're working on linked lists and stuff like that, using pointers to jump from places to place in our memory, because arrays require sequential or contiguous. It's a weird word. I want to say it's contiguous, like they're the memory blocks have to be right next to each other. But linked lists don't. We can have well, for those of you that can see me on the camera, we can have element 0 here. We can have element 1 way over here. We can have element 2 above it. We can have the elements all over, and we'll just use pointers connecting them, as I'll show you on paper in a second, to move about. And then when we want to, we will dereference. And when you want to change values, you can change values that way. If we wanted to change the value there, how could we change the value? Yeah, I would dereference B pointer and say it equals B pointer +1. Oops. That's how we could increment it. So we could do that. I'm going to comment that out. Well, let's show it. What happened here? We got B pointer was 1. I dereferenced this one. So we upped it by 1, so it was up to 2. And then we added another one, so it got to 3. Okay. So yeah, it's working as we thought. What else we got going on? Fuck. So we got a nice little loop. It's telling us the address. It's doing pointer arithmetic to hop between locations to tell us what it contains. So I'm going to comment out that line again because it threw off our sequence here. Note the parentheses. Okay. That's 1, 2, 3. I'm going to change 1, 2, 3 to say 2, 5, 8. So all I've done is change the array, chose different values. And that should still tell us 2, 5, 8. Notice if I copy this line and remove the parentheses, what happens? And I'm going to put another end line in here to have a gap show up. So we got two different things going on here. 2, 2, 5, 3, 8, 4. So 2, 5, 8 was the original line where it's going to the right thing. But if we don't have the parentheses, it keeps pointing to B pointer, and B pointer is a pointer to the first element. So all we're doing is adding values to the first element, which was 2. So the second line there was 2, 3, 4. So if you don't have the parentheses, it's just adding something to the same thing. You definitely want the parentheses. Is that clear? All right. No, that's all we got for that one. I'm gonna comment that one out because I will post it. Even though I've copied it from the module, we have made some edits. And I will come down here and start anew with where is it? Where is my class? Now we're going to look at functions and functions with pointers. So I'm grabbing the second set of notes. All right, let's take a look at what's going on here. Still declaring x equals 5. We've still got a pointer, x pointer equals pointing to x. We've got 3 functions listed. Square fun 1, square fun 2, square fun 3. Functions, as a reminder, the thing in front is the output data type, and the thing on the inside is the input data type. So this first one, we're just passing the value, passing an integer value. Here we're passing by reference with the address. And on the third one, we're passing by pointer. I don't know why that's doing that. I'm betting that's just a glitch right now. Let me hit run. Yeah, it was not an error. All right, so let's take a look at what's going on here. And let's see, let's go down and look at the functions. So square fun 1, we're gonna, whatever we're passing in, pass times pass is basically squaring it. And here it says pass equals 10 and it's returning the result. So we passed in 5. 5 got squared to 25 and set to the value of result. Then they changed pass equal to 10 and then return the result. And we got 25 on the screen. This line did nothing. Nothing was changed in the original. And it didn't change the value. I know it didn't change the original because it says X after function call equals 5. Okay. So it's just checking to see, did this edit our memory? Did passing something to our function edit our memory? When we passed by reference using addresses, which is what we did here, even though this has an address on here, notice we can just pass X normally here. That's pretty fucking convenient. That's easier to remember when I'm typing shit in, right? What happened there with square function 2? Square function 2 squares it and then changes past the 10. In fact, they're all doing the same thing, except this one's got pointer stuff on it. But square function 2, it squared it just fine. Then it changed X to 10. So what this line edited the original value of X in the main. So when you pass by reference to functions, this should be old news from CSCI 1, just a reminder. When you pass it by reference, you can change the value. So now when we get to square function 3, X pointer is pointing to X, and X is now 10 from this section. So it's passing in 10. 10 squared, we have to do the pointer here first off. We have to send in the X pointer. Again, I don't need any special symbols there. I just said X pointer. But here we have to remember to dereference it each time. Here we dereference pass equals 20. You dereference pass, we set dereference pass equal to 20. Pass was a pointer to X. So we are dereferencing that. So we're getting the 10, and the 10 is being replaced with a 20. And that's what it says right here. X after function call is 20. So this is affecting everything as well. This affects the main as well. And we saw that in the main, not doing functions. When we dereferenced it, we could change the value. We did it by adding 1 to the value. But these two do similar things. They both pass something. They both of them edit the main value and the main function. One uses references with address referencing. One uses pointers. To me, in my head, this is tedious. Why does this not have an end value? Is it off screen? Yeah, it's off screen. This is tedious remembering to do this, but this, okay, well, maybe I'll put the comment here. Square Fund 2 and Square Fund 3 have the same results. Spit out the same shit. And both edit the value in the main. So I would think using pointers is harder to remember. Is more work to code. Yeah, that's once you remember how to do it, it's fine. It's still just more work to code. However, what happens with arrays? When we're using arrays, both will work just fine. It's doing the same thing. When using linked lists, as we'll be doing later on, the first one, function 2, sucks. Because it requires more shit. You got to tell it the address, and the address is not the next element. You can't just do pointer arithmetic anymore. And doing address arithmetic, like using I in a for loop, doesn't work. Pointer arithmetic works just. Make sure everyone's done typing that before I unfortunately turn on the camera to draw what's going on here.
Recording in progress.
Oh, I have to stop screen sharing over here. All right. So when we started off, we had the char array, and it was 1. So A was like this. We had J here, we had U here, we had A here, we had N there, and we had 0 there. This was A0, A1, A2, A3, and A4. And using I here works really well. In for loops. The linked lists and stuff that we're going to be doing doesn't require contiguous memory. This is a weird word. CONTINGUOS memory. Which is really just like sequential memory. I don't know what the difference is. But when we have a list for this, we can have J here, we can have U here, we can have A there, we can have N here, and we can have bracket or no pointer there. And A pointer points to that. And A pointer plus 1 will point to this. And A pointer plus 2 will point up here. Well, A plus 2. This is changing the address. It's shifting to what it's looking at each time. Non-sequential memory. That's where we're going. Because let's face it, all of you that got big fucking video games, does anyone here not play video games? Okay, good. A lot of video games take up a fucking shitload of space. How big was fucking Elden Ring? A lot! A lot of fucking gigabytes. Do you want to have that shit all in sequential order in your memory? when I was a fucking teenager, you guys might remember us kids. We haven't had to do it in a long time. You just have to keep track of the fucking computer all the fucking time. Because it would always just, as you add a new code or save new programs, it was like filling up the fucking whiteboard, filling up the page. And as you deleted code, it went and erased the middle of the whiteboard. And now you can only use that section if the next program you wanted to put there was the right size. That size or smaller. So defragment, what it did is says, all right, we're gonna get rid of all the fucking white space, and just like move everything to the left, and then we'll have all the room on the right of the whiteboard where we can store shit again. That's how we had to used to do it. They didn't do all this jumping through hoops with fucking linked lists and stuff like that. They do a lot of stuff now where you don't have to defragment your computer. It can be saved anywhere because the computer knows how to hop from cell to cell, or square or address spot to address spot. So that's where we got to go with that. That's where we're going to go this semester. Let me hit stop share and leave that one so we don't have the fucking volume. Come back over here, share screen again. All right. So when we pass by value, we get a copy. We're not fucking with the copy. Oh. I remember there's fucking so much shit to try to allow students to stay home and do this shit at home. But it's worth the job. Once I got it figured out, we won't have this problem every day. So when we just pass stuff, we're not editing the original. When we pass by address or pointer, we're editing the original. Passing by address is pretty easy. Nothing in this code was different. Notice these lines are fucking identical. The entire function was identical. The only thing that was added to pass by reference was this ampersand on the data type. That's the only spot. We come up here to the functions, nothing changed up here either. So passing by reference is really easy, but it requires contiguous or sequential memory. Pointers, as you get used to them, it's not too bad. The real bitch lies in remembering to fucking put shit in parentheses. Right, Juan? Any questions? Okay. Well, we're ahead. That didn't take as long as I thought it was going to take. Let's see. Is there anything else I wanted to say here? I make little notes to myself of what I want to say in lecture. I try not to wing it like Red does. There is some winging it because like student input, like, oh, let's try something out. But there was stuff I always wanted to say. Drawing the picture helps. We're going to be doing this picture thing a lot, especially when we get to linked lists, because figuring out, like I drew the arrows just fine, but that's because I'm using pencil and paper. How do I tell it to the computer to do those arrows? That can be a little bit more work in the code. But once it's in there, and everything works just gloriously. Yeah.
It's not the word. How would you put, say, up there
In your header files?
like putting it in different files? So like let's say you get yeah. We're gonna hit that.
Well, yeah, we'll hit that. We're going to do a lot of stuff with separation. I'm not going to have you do anything with header files and like this shit over here. The resource files, header files, source files. As it is, we're going to do everything in the source or the main, just because like trying to submit shit to the teacher is a fucking pain in the ass if you're trying to send in 3 different files. Having it as one file is fine, but we're going to have you do proper, like good separation within it with prototypes up top, implementations of functions down below, which is kind of like what's going on right here. Where is it? this had function implementation. Yeah, okay, so these are function prototypes above. And below the main, function implementations. We have to have them that way when they're all in one file because the main needs to know they exist. And it won't read later into the code to see if it exists afterwards. So up here, these prototypes let the main know there's something to these and to look below. When we're using this as C-type function, yeah. When we do classes, when we start doing with the classes, I don't really know that we have time. You want to jump it? Should we jump into templates? Dabble or wait for Wednesday? Let me take a look at our schedule here. Oh, I have templates and inheritance for 2 days. That's way more than we're going to need. Other than playing with it. Yeah, I guess we'll call that for today. Unless there's any questions. All right, so if you want to go home, you're free to get the fuck out. If you want to stick around and ask questions, Juan's here till 8. I'm here till 6. We'll get this worked out online, people, so that it goes fluidly each time.
All right. Have a good day.
You know what? I didn't even think if anyone else in this room beside you had Zoom open. If anyone's mic was on, that might have been causing that fucking feedback. Yeah, it's because it's picking up. It was picking up staticky sounds, like not like. We'll try it. We'll try it ahead of class next time. Let me hit stop record.